Okay. Sorry about that, just getting everything set up over here. Welcome everybody to day 6. It's already day 6. I had to double check when I typed it in to make the stream. Day 6 of Try Hack Me's Advent of Cyber. My name is Joseph, and welcome to Learn to Defend Cyber. Today we have a special treat. I've been told that apparently we are getting to look at some Yara rules. Yara rules are used for detections, making detections based on any kind of strings or maybe behavior. We'll see what we have in store for us today, so let's go ahead and pivot over. Very, very cheery. I did not select the web screen yet. Oops. How's the level on this music, by the way? It feels loud in my ears, but I could be wrong. How's it going, Haircut Fish and Rhonda? Welcome to the stream. Thank you for joining. So let's see. Day 6. I don't have any of the machines set up. Let's go ahead and get things spun up first. Do we need to start an attack box? We don't need an attack box. Looks like everything will be done in this split screen over here. Everything sounds okay. We just started. We just started day 6, so no idea yet. So let's see what we got. Day 6. If I can't find a nice malware to use, I'm not going. Mayor malware was scheming, quite full of delight, to ruin Sockmas and frighten Sock teams. But Glitchy McSkitty had spoiled his plan by uncovering secrets that exposed the man. Mayor malware slammed his hand on the table, his eyes narrowing. As the report flashed on his screen, Glitchy McSkitty had uncovered his trail. He took a deep breath, calming himself. No matter, he muttered, a sinister grin forming. They may have found me, but they haven't stopped me. His confidence stemmed from the malware he had crafted, so devious and advanced that it would easily evade detection. So it's gonna sound like it sounds like we're gonna be talking about some possible counter-forensic techniques or anti-analysis techniques. One final step, he needs to test it in a sandbox. Okay. So we're gonna be looking at malware behavior using sandbox tools. Explain how to use Yara rules to detect malicious patterns, learn about malware evasion techniques, and then implement invasion technique to bypass Yara. So we're doing a little bit of both, it seems. It sounds like we're going to be both looking at how Yara rules work and then implementing ways to get around a Yara rule that we either make or is created already. Thank you for posting that link, Dan. Very, very much appreciated. That's the link to the Advent of Cyber right there. So let's talk a little bit about how Yara rules work before we dive into this and while things load. Yara rules, there are quite a few ways to use them. They're usually paired with EDRs or SIMs to generate alerts based on... Well, that's interesting. An error has occurred and this action cannot be completed. If this problem persists, please notify your system administrator or check your system logs. I think we might need to restart this machine. Let's try this again. I don't think that's supposed to happen. Let's try again. Alright, as we were saying, Yara rules. Yara rules... used with SIMs and EDRs. We talked about those a couple days ago. SIMs is security information event monitoring systems, and EDRs are endpoint detection response. Typically a software. They are burned into your kernel or have some kernel writes typically so that they can detect any kind of rootkits, bootkits, etc., as well as monitoring behavior and looking for patterns that are known for different malware, so that they can prevent them, send alerts to your SOC analysts, and hopefully stop you from getting pwned. It's still loud in my ears. I'm just going to turn it down on my own. I don't think it doesn't look like it's that loud on stream, so we're good. Alright. Hopefully the machine spins up this time. and doesn't do whatever it did a moment ago. Alright. So let's talk about sandboxes. Looks like we're introducing sandboxes here. Sandboxes are basically just virtual machines where you would go and detonate malware on purpose, because you don't want to run malware on a live production system, and you definitely don't want to run it on anything that contains sensitive data. For instance, your personal workstations. You would either want to build a computer specifically for analyzing malware, or you want to use sandboxes, which are virtual machines with tools on them specifically crafted for analyzing malware. And we did this because there were too many instances of people getting themselves infected with whatever. What is going on with this sandbox? It's not good if we can't get this to work. We'll try it a third time. I'm wondering if they're having issues over at TryHackMe. Alright. Sandboxes, as we were. We use this technique so that we don't infect ourselves, and it also is just a great way of having a bunch of tools stuck together and having a clean environment every single time you want to look at a new piece of malware. And we use these sandboxes to find maybe different ways that they call processes, or they call... They may have certain strings they use, or different behaviors that are unique to this malware, and we can analyze this and generate rules for Yara or Sigma or other ruling structures to try and detect this when they go off, so we don't have them popping off in our environments and us not knowing. Now, since we started using sandboxes, the natural course for attackers or ethical hackers, whoever was creating malware, was to try and detect that we were using sandboxes, and they started using anti-sandbox techniques to figure out that they were in virtual machines, or maybe they were in specific sandboxes, and prevent themselves from running. You can do this by checking your registry keys. I think here it says... to open the window, blah, blah, blah. The directory is often absent on sandboxes or other virtual environments. So this program files directory in your current version registry key is usually missing in sandboxes. There are other telltale signs. You can check the baseboard, which is your motherboard, using a command, and that gives you telltale evidence that you're on a virtual machine. There are a lot of different ways you can check. And then, of course, the challenge becomes, how do we get around those checks? Please work this time. Third time's the charm? Looks like we got it. Alright, cool. Third time's the charm. I don't know what's going on with their machines over there, but looks like we're running and everything's working now. Awesome. Weird little glitch. Happens sometimes. View in full screen. Because we want to be able to see what we're doing, we can close out the split view now and go back down to where we were. So, what are we doing in today's challenge? Let's find out. Okay, it looks like they want us to go and look at the registry, so we can go ahead and do that. We'll go to regedit. That's how you get... Oh, it was already typed in. I didn't even need to type it myself. And they want us to go look at the software, Microsoft Windows current version. So HKLM, which stands for Hive Key Local Machine Software. Microsoft. Right, that's where they wanted us to go, Microsoft. No, they wanted us to go to Windows. See, I have bad memories. Alright. Software, Windows, right? Come on, come on. Software, Microsoft Windows. I had it right. I can't read. Alright, software, Microsoft Windows. Okay, we'll expand this one. And then they want us to go to current version and look for We'll expand that folder and look for that program files directory. So let's look in current version. You can see that we have the common files directory, we have program files directory, both present on this machine. Typically, it says that we would have them absent on sandboxes or other virtualized environments. Because Flare is a specialized virtual machine, they probably have these keys in here to counter those anti-sandbox techniques. Flare is a machine specifically for analyzing malware. So there's probably a lot of things in this virtual machine that aren't typically on virtual machines, like that program files directory. Alrighty, so we saw that we have that registry key, and now we have some C code. And this is C code that looks like it is checking registry path to see if it exists. So you would have this in your malware or whatever to check to see if that exists. Now, if it exists, you can be confident that you are on a normal machine. If it doesn't exist, that is where you would probably have an exception thrown. We can see flag redacted, so I'm assuming there's a flag in this when we run it at some point. You would probably have an exception thrown to either silently uninstall itself or do some other action so that it doesn't look like malware, because it doesn't want to get found out, right? All you need to know is that this function is designed to check the system's registry for a specified directory path. Yep, okay. Presence or absence helps the malware determine whether it's running in a typical or virtualized environment like a sandbox. Yara. Mare Malware knows that McSkitty is a big fan of Yara rules. Yara is a tool used to identify and classify malware based on pattern in its code. By writing custom rules, analysts can define specific characteristics to look for. So, yeah, as it says, we can write rules to look for things. Mare Malware does not think such a simple tool can detect his malware. Just to be sure, he has to test it himself. So, it looks like he's writing a Yara rule. And we are going to flag on detects the sandbox by querying the registry key for program path. Looks like we are flagging on anything that checks that directory. And because we know that in this malware, it checks the registry and it queries that directory, right? So what we're going to do is we're going to write a Yara rule. It's already written for us. I'm sure we don't, I don't know if we have to write this or not in the machine yet because I haven't read that far. But this is what an example Yara rule looks like, and it's a pretty decent example. It's very, very specific. It only alerts when something queries from command. Or sorry, when anything queries the program files directory registry key. And we can see it defines the string and then the condition. Yeah. Okay. First testing Mare Malware. This is just the block explaining what I just explained, by the way. I was just making sure I didn't miss anything. I don't want to lead y'all astray. First testing Mare Malware has set up a one-function script that runs the Yara rule and logs a true positive in our tools yaramatches.txt directory. Open up a PowerShell window and navigate to the tools directory. So let's go ahead and open up PowerShell. It didn't say we needed a privileged one, but we're already administrator anyway. So where are we? We are in users administrator. So let's just go ahead and CD down to C, and then CD to tools. Okay. So now that we are in the tools folder, what do they want us to do? Looks like they want us to run jinglebells.ps1. That is our script, it seems, that is going to launch that Yara rule. So let's go ahead and run that jinglebells.ps1. It's running, says that it doesn't find any events in our sysmon log. We have sysmon on this machine. We talked about sysmon a little bit the other day. Sysmon, a wonderful tool, is basically just a tool that provides more verbose logging than your typical Windows event logs. and it has far more logs generated on different actions, and it gives you a little more information. So we can now run the malware that Mayor Malware has created, or us in this situation, since apparently today we are Mayor Malware, and we want to ruin Christmas, or Sockmas, sorry. And let's go ahead and go to our malware folder and double click on merrychristmas.exe. Got our malware folder right here, and click on merrychristmas.exe. We see a random command prompt flash up. You know everything's fine when you see random shells and prompts flash. Everything's great. I say that in seriousness. If you see random PowerShells and command prompts flashing, usually a bad sign, obviously. But we can see that we did detect it. Got a result, sandbox detected. And we can see where it was detected, where it logs it to. We log to that yarmatches.txt, what time it happened, the event ID, the event record ID, and what command line was there. We queried the registry for that directory that we had that rule, and then we have some more information that it gives us right here, more just kind of the same. So we can go back to tools and look at that yarmatches.txt, and we see where we ran it. This is the result. This is our log showing successful detection of that registry query. Okay. You should have witnessed a pop-up by our EDR with a flag included. I did not get a pop-up, I don't think. Did I? I did get a pop-up. It's behind all of my context windows. Here we go. Malicious command detected. THM glitch was here. So I assume that's a flag for a question later. What was the flag displayed in the pop-up after the EDR? Yes. So this is our first flag. Glitch was here. Make sure to turn that into a curly bracket. Glitch was here. Close the curly bracket and submit. Boom. Alright, back to where we were. Now, we have to think about... Just pull everything I had up so I make sure that I still have everything. Alright. We have to think about that our malware has been detected. How are we going to avoid this? Adding evasion techniques. I assume, yep, I can see it right here. I don't even need to scroll all the way up to the end. I can assume, yep. So it looks like we are going to encode our command in base 64. I'm just going to go ahead and copy this whole line, and we will go to give myself malware for freezies. It's on a GitHub page, of course. Alright. We can go from base 64, and we see that the get item property, that's kind of hard to read. Usually when you decode from base 64, if it was run on a Windows machine, you're going to have to go ahead and grab the decode text and get it from UTF-16 LE, also known as Little Indian. Get item property path. This is just querying that same registry key that we queried earlier. Hurry up, we gotta save it. It's like gambling. I need that prompt. What prompt? Oh. I think Dan was telling me. You can also just use remove null bytes. Yeah, true. But UTF Little Indian is the encoding system. So using decode text just also gets rid of the null bytes. So we went ahead and obfuscated our code here, and it's going to do everything the same except for it's going to call that encoded command and then give us our same output. We already went through CyberChef. Beware of floss. While obfuscation is helpful, we also need to know that there are tools available that extract obfuscated strings from malware binaries, such as floss, which is a Mandiant tool. A powerful tool, oh, it says right here, a powerful tool developed by Mandiant that functions similarly to the Linux strings tool, but is optimized for malware analysis, making it ideal for revealing any concealed details. So, we have that Yara rule running still. Let's go into our malware real quick. And I can show, because I assume this OBF stands for obfuscated, that that when we run this, that Yara rule is probably not going to detect it anymore, because we were looking for the string, specifically looking for that query to the registry. Yeah, I'm not getting any kind of output. Let's go double check our log. Nothing was written. We can go ahead and close it and check it again just in case. Nothing was written, so we didn't detect it. Because we were so specific that we were looking for a string that interacts with that registry key and that specific string, we did not detect the launching of the malware. So they want us to go ahead and use floss now. And it breaks down this command. They went ahead and provided us a command, thankfully. We can see here that it strings, or the tool is being, oh my god, I'm having a brain fart, sorry. We are using floss to detect, or to look at the Merry Christmas executable binary. Same words really, executable or binary. Trade them. And then outing the file to malstrings.txt. So let's go ahead and run that. We'll do a new shell. We will not, because I'm going to have to change to that directory first, I assume. Alright, let's try this again. Take away the very beginning, just run the executable. Okay, it's working here. I remember seeing that it said it was going to take a second so we can continue reading. Yep, so this is called a pipe. Piping takes output or redirects output of the command in front of it to the input behind it. So this is in front of it, this is behind it. Takes the output of this and redirects it to this command. And then out file takes it and puts it into a malstrings.txt. Once we're done running the command, it looks like we can Control F for a new flag. And then Yara rules on sysmon logs. So sysmon, as I was saying earlier, is very verbose, and we can use it to look at how we might use Yara to detect different actions that this malware is taking. So instead of just flagging on that string, we can maybe flag on a process creation, or maybe we can flag on how a process interacts with something else, right? And we would do that by going and looking at our sysmon logs. It looks like it completed too, so we can go and look at that too. We can go to our sysmon logs, which are in applications and services logs. Always takes a moment to expand on these VMs. It's considering it. No? Okay. Event viewer is not responding, which means it's working. Microsoft, Windows, all the way down because it's in alphabetical order. And here we are in sysmon. Let's go to the operational logs. And here are all of the sysmon logs generated. It's quite a few of them. So, how can we use this? If he wants his malware to be undetectable, he needs to research how Yara rules work. Yeah, how they can be used to stop him. For example, his research tells him that Yara rules can also be used to check sysmon logs for any artifacts left by malware. Sysmon, a tool from Microsoft Sys internal suites, continuously monitors and logs across reboots. Yes, it does. It is persistent. And also a great service to output your logs to your sim so that you have a little bit more data enrichment. Yara rule will look for events with event 1 or event ID process created for this to work. There are many entries in the sysmon log. To make it easier to find the event we are looking for, we will apply a custom filter using the event record ID that we can see in the Yara matches.txt log. So earlier we ran. We can go ahead and close this one because it looks like we're done. Oh, we got that mal strings text as well. We can dig into that in a moment. We can see that we have an event ID. This is your sysmon event ID. Go ahead and copy that. Go into our event viewer and filter our current log that we're looking at. Sorry, wrong field. Go to the XML. Custom filter, yeah, that's what I thought. Okay. Keyword. We can look for just this event ID where we can try. Maybe it doesn't go in the keywords. Doesn't go in the event ID. Where does it go? Oh, it did want us to use the XML. Okay. So we learned a little bit about XML yesterday. I thought they wanted us to use the XML, but I did not know if there was a quicker way to do this. And they give us some XML to use right here as well, so we don't have to type it ourselves. No one has to point and laugh as I try and do it myself. And then we can insert that event record ID we got earlier. Or we can not. Copy. And then paste it right here. Okay. And we find the log of our execution of the malware earlier. So we can see that command.exe is what process was used to push the command line, querying that registry key. Oh my lord, registry key from the malware directory. We can see which user did it. It was us, the administrator, because that's who did it. We are the ones executing it. We can see the image name. These are all things we can create detections on. There is a thing called the Pyramid of Pain. It is it's literally a pyramid of different ways you can identify threat actors or their tools or their malware. Names are pretty easy to change. Hashes are pretty easy to change. But changing how your malware is querying from command may be a little bit harder. So we would probably want to write a Yara detection that detects command.exe interacting with the registry. And really, honestly, command shouldn't be interacting with the registry much at all. There are legitimate reasons for it, but it's just a nice detection to have. We got Brandon Maverick. Welcome, welcome. All right. And that's the friendly view of what we just went over. Yep, and we go over some of the different artifacts that I just described, parent image, the process ID, which that isn't really necessary for detections, but it is nice for seeing how different things were interacting with each other, and looking at other relevant logs so we could see if that process ID was relevant in anything else. And then we have the user, what it used, the command line, and then what time it was done for creating a time frame. And now we get to read some more of the story. His malware, it seemed, wasn't quite ready for town. There are watchers and scanners and rules by the ton. If I'm not careful, they'll catch all my fun. Mayor Malware leans back, tapping his fingers thoughtfully on the table. All of this research had revealed an unsettling truth. His malware, as cunning as it was, wasn't ready for the wild. There are too many tools and too many vigilant eyes. Analysts armed with Yara rules, Sysmon, and a host of detection techniques that could expose his creation before it even had a chance to spread. He clenched his fists, a determined glint in his eye. Just a little more fine-tuning, he murmured. He would study and adapt his malware until it was truly undetectable. When the time was right, he would unleash it upon the unsuspecting SOC teams, striking when they least expected it. But now he would wait, watching and planning, perfecting his craft in the shadows. So yeah, he wants to go ahead and make his malware undetectable. There's a lot of ways that this can be done. There are a few different techniques. You've got your wrappers and droppers. The more complex you make your malware process, the harder it is to detect what's going on, but the more artifacts that you are leaving behind. So sometimes some may argue that simpler is better. If you have something that does it and it's very, very, very quick and quiet, and it blends right in, and it's not doing anything that's overtly obvious like querying the registry, then it may go undetected a little easier. But if you have malware that's coming into an environment and it's dropping, it uses a dropper to maybe drop a payload for stage 2, or it drops the true payload. You have different points in the process where you can detect this. Oh, it calls to this website to grab this dropper. Oh, it has this file hash for the dropper. Oh, it has this for the wrapper. You know, there are a few different ways that you can look at it, and it goes way beyond today. But there's a room of Flare VM arsenal of tools. Flare is a great VM, by the way, and we do have to find that flag that said it was in the mal strings.txt. So we can see different strings that Floss did find in that malware payload. And if we control F, we were told to look for the THM. You can find it right here. Here's our flag. Awesome. And that is it for day 6. Now, I would totally look, if today interested you, I would look into Dr. Josh Stroheim. He works at Mandiant right now, I believe, and he is a reverse engineer of malware. That is a whole career path. If you like coding and you like figuring out how malware works, then I would totally recommend going down that path. Let's see if I can find Dr. Josh Stroheim. Stroshine. Sorry, I always say his name wrong. Josh Stroshine. And here's his channel. I can pull it back up. I'm not subscribed on this channel, but I am subscribed on my main account. Cyber Yeti. Plenty of different things you can see. Reverse engineer. Okay, he works at Flare, which I think Mandiant owns. Rapid and base 64 10 times. Just really obfuscate that string. He does great content. He has plenty of playlists on how malware works. So if you were interested in this, I would definitely recommend looking out his channel. Looking at his channel URLs right here. And there are plenty of Try Hack Me rooms, it seems, to go over the Flare VM and seeing a few different things and talking about reverse engineering and debugging in general. So that is it for today. I'm willing to let it run for a few more minutes, answer any kind of questions, talk to chat. But overall, Thank you for tuning in. Let's see what we got. How's everybody doing today? And we went a little quick today. I know I have to do some Christmas shopping, such as the time of the season. We are on Friday. For the weekend, by the way, I will be running my stream at noon tomorrow, noon Eastern, and then noon Sunday. So weekends should always be noon. Christmas shopping as well. Yeah. This year I'm trying not to wait until like the weekend before Christmas. I want to actually have it done so that I'm not stressing. I was told that my Christmas music was a little too calm, so I decided to try some more upbeat Christmas music. I got my shopping finished about an hour ago. Ah, really early. Christmas lights with the kiddos, and that's why Amazon is for just order it. Yeah, but sometimes you want to see some things in person, right? I need the Christmas music to make me feel like Santa is going to attack me. I'll get some Christmas heavy metal then. That is a thing. There's like Christmas flavors of everything. FedEx says no. We don't have to go in person. You would just get everything on Amazon. You don't know if you like it quite yet, but if you get it on Amazon and you don't like it, you just return it, right? No, I still prefer to go in person, especially for the local businesses. Go in and help them out. Rage Christmas music. There you go. This is like Mario Bros. Christmas. No, not quite. I mean, I guess like maybe modern Mario. Yeah, I could see that. I like it though. It's a little upbeat compared to what I normally do. You're speaking my musical language. I hear you, man. I like rock. I like metal. I like all flavors of music. You can see I have guitars back there. That one, I have heavier strings on just for shredding. So. And it was going to drop tuning a little bit better. Santa better be shredding. You know, honestly, if I hear reindeer on my roof and then crazy electric guitar, I don't know if I'd be afraid or welcoming of what would happen next. All right. And with that, I'll go ahead and close it out for the day. Thank you so much for tuning in. AI, it's creating tunes, but it's not PGA. I've not used AI for music. Alright. Thank you for tuning in so much. That was day 6. It was a good time. I look forward to day 7. I will see y'all tomorrow. Have a good day.